This is version 9 of the dash module number 3. In this video we're going to take a quick introduction, overview of the unit, and we're going to look at the connections that need to be made to the unit and also the key user options. Now there are many user options which allow you to customize the unit. We won't look at all of them in this video because there are far too many, but we'll look at the key ones which need to be set. Now as you can see, the unit now, this version 9 of the unit, is a single circuit board. Everything's been fit onto a single circuit board. It is, however, a 4-layer circuit board, so the complexity of the board is quite substantial. So let's now take a look at the main connections to the unit. Okay, first of all, right here we have a 2-pin screw terminal connector. And that allows us to put power into the unit if we don't need to use any of the other inputs. If you're just going to use the voice display, then you can simply connect the positive terminal, a fused positive terminal of the supply, into here, and the negative side into here. Right here we have a 3-way header which allows us to select either the microphone or the RCA phono type input as the source of the signal for the voice modulator. So you can see that if we put the header in this position, joining the center pin to the right hand pin, then it's going to use the microphone input as indicated by MIC on the board, right there. If we move the header over from that position and join the center pin instead to the left side pin, where it's marked LIN for line, then it's going to use this audio input, for example from a car stereo, as the source of the voice modulator display signal. We have two what are called JST type connectors on the unit. One is a 10-way connector here, and one is a 20-way connector here. Now the 10-way connector is going to be common, i.e. the same on all version 9 dash modules, and it has a pinout which will be the same across all modules. So let's go through the pinout for this unit, because this is the one that you'll really need to connect. Now here is the plug which mates into that, and when we connect it we'll just push it in here with the little tab at the top, and it'll snap into position. But let's first of all look at the wires in here. Now the wires are numbered like this, so that at the lower right is pin 1, and then it counts 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So pin number 1, which is lower right as looking at the back of the connector, is this red wire. And this is the wire that we use to put power into the unit, which we recommend is accessory switched power. So it's not on all the time, but it is on when you put the key into the accessory position. You don't have to start the engine to use it. Pin 2 at the top here is this white wire, and that is the ground switched signal for switch number 1. Now what do I mean by a ground switched signal? Well, ground switch discretes or low side switch discretes are signals which are either connected to 0 volts, that is ground, when they're active, or alternatively open circuit, that is connected to nothing, when they're inactive. So this input here, pin 2, which is the white wire, needs to go through a switch, a latching switch, down to ground. Pin 3, which is this one right here, is a brown wire, and that connects to the lights. Now you don't have to connect this, but if you do connect it, it allows you to exercise certain functions, like for example dimming the display when you switch on the car lights, and also we've included the feature to switch off the dash-top indicators when you put the lights on, because that can be distracting as it reflects in the windshield. Pin 4 is another ground switched input, and that is to connect to a push button, and that one is on a yellow wire, So that's this one right here on the top row, second in from the right. That's push button number 1. Pin 5 is a pink wire, and that is connected to the secondary ignition power. Now the Firebird has 2 ignition sources. One is on the whole time when you switch the engine on, and that is what we call the primary ignition power. The secondary ignition power is another ignition signal which is cut out temporarily while you're cranking the engine, so that it's only driving the essential things for starting the engine. So you don't have to connect that one, but it's useful, especially if you're using the dash module number 3 in its fully functional mode, where all of the side indicators and the dash top indicators have real functions. Pin 6 is going to be a blue wire, and that is this one right here, the middle one on the top row. And that is another ground switched input, this time to push button number 2. We'll talk about what these push buttons and the switches enable you to do later in the video. Pin 7 is a connection which goes through a potentiometer, enabling us to vary the brightness. That's this green wire here, second from the left on the bottom row, and enables us to connect to a potentiometer, i.e. a variable resistor. And I've put on this diagram here CW pointing to the right. That means if you turn it clockwise, then we're moving the wiper, the middle pin of this potentiometer, to the right. So turning the potentiometer clockwise will increase the resistance, and that will increase the brightness. You don't have to connect these again. If you disconnect these altogether, then you'll just get maximum brightness because you have a high resistance between pin 7 and ground. Pin 8 is a grey wire. It's another ground switched connection, and it's the second from the right on the top row. And if we connect that to ground, it will just reset the unit. Pin 9, the leftmost wire on the bottom row, is a purple wire. It's a very dark purple. It looks like it's black in this video, but it is actually purple. And that is potentiometer number 2. Now the difference between potentiometer number 2 and potentiometer number 1 is that potentiometer number 1 varies the brightness of the voice display, and potentiometer number 2 varies the brightness of the side indicators and the normal auto pursuit indicators. There is an option, another user option, which allows us to just use the single potentiometer to drive both, but normally in the default configuration we'll have pot number 1 varying the brightness of the voice display, and pot number 2 varying the brightness of the side indicators and the NAP indicators. Again, as we've mentioned, if you don't connect those at all, that's no problem, it just gives you maximum brightness. And pin number 10, which is the leftmost pin on the upper row, is a black wire, and that is just a ground connection to the unit. Now, any of these pins which you don't use, you can easily just remove the pins by, if you look at this this connector closely here, you see that each pin has a little plastic tab, and if you just get a very small screwdriver and raise that plastic tab, you can pull out the wires for unused connections. So that will make the harness a little less confusing if you pull out the ones that you don't need. Let's continue then and take a look at the second of the JST connectors, this 20-way connector. Now this connector is for inputs which are specific to module DM3, as opposed to this one which is generic and the same on all modules. So this one then, again, it's a 20-way connector, and it has a similar kind of connector but just bigger, and it has the same arrangement where this little locking tab is at the top, and you push down here to open that, push it in, and it will snap into position. So let's go through the connections on this one then. Pin number 1 is an orange wire, which is at the bottom row and the right hand pin, and this is a 12 volt connection, which is a 12 volt output from the dash module number 3, and you probably won't use this. The main reason for this is to enable us to test the unit easily on our test bench, because this puts out a 12-volt signal, so that enables us to drive switches which represent high switched inputs. We're talking about high switched and low switched inputs again. Remember, we spoke a short while ago about low switched inputs, which are either connected to ground, 0 volts, or they're open circuit, connected to nothing. Well, a high switched input, a high switched discrete, as you might expect, is a signal which is either connected to 12 volts power when it's active, or open circuit, that is connected to nothing. So this 12 volt output on the orange wire enables us to hook up switches on the bench to easily test out all of the other inputs. In the real car you probably won't need this connection, so I suggest this one you do actually remove, again just by raising this small plastic tab and pulling the wire out. Similarly, pins 19 and 20 are black wires, and those are ground connections. Again, you won't really need those unless you're using the unit on a test bench, so you can either tie them back or you can remove them, as mentioned earlier. All of these, let's just mention first of all the NAP connections. Now, this unit can be either configured to have functionality only on the normal auto pursuit indicators, that is these here immediately under the voice display, or they can have fully functional inputs, such that the dash top indicators and the side indicators are all fully functional. Now, if we select the functionality so that only the normal auto pursuit indicators are active, are functional, then these ground switched inputs on pins 4, 6 and 8 will give us the functions for normal, auto and pursuit. And in that case, all of the other inputs will have no function whatsoever. So if you're only going to use normal auto pursuit inputs, you can disconnect everything except the green, yellow and red wires on the top row there, and yeah, that's just about it. That's all you'll need. So let's look at the other inputs which you'll need if you're using the module in its fully functional mode. First of all, we'll leave this brown input until last, but all of the other ones, this pin number 10 here is a spare ground switched discrete input. So that's like the normal auto and pursuit, it's a ground switched input, but it has no specific function in the default configuration. If anyone wants a customized version of the software with a ground switched input, we can provide that on that pin and write custom version of the software to accommodate that. These other high switched inputs on the top row are red wires with a black tracer. So all the high switched discrete inputs on this connector are red with a black trace, and that's pins 12, 14, 16 and 18, which are the fasten belts input, the rear window defroster, the rear fog lights and the nose lights, that is the lights in the custom nose. Also on the bottom row we have some more high switched inputs representing high beam lights, low beam lights, right turn signal, left turn signal, ignition power number 1, that's the primary ignition power, as opposed to the secondary ignition power, the starter motor input, and again 2 spare high switched inputs which normally aren't used, but we can actually write custom software for specific applications. Let's just finally take a look at this input on pin number 2, which is a brown wire, and that goes to one of the outputs of the alternator. Which output, I hear you ask? Well, if you look at an alternator, and if anybody's really interested, and you can make it until the end of this video, I'll speak a bit more about what happens inside of an alternator and what these various connections represent. But suffice it to say at this point that this pin number 2 on the brown wire connects to one of the pins on the alternator, not the one which is connected to the battery. You'll find that on the alternator you'll have a big output, which is the main power output, which connects to the battery, and that output will also be connected to one of the smaller terminals. Now the other terminal, which will usually go through a warning light, a charging warning light, or on the Trans Am it goes through a brown resistance wire. you'll connect this voltage here, you'll connect this wire here to that point, and the voltage difference between the battery voltage and the voltage being generated there is an indication of whether the alternator is charging or not. So if that light comes on, it'll come on when you first turn the ignition on before the engine is running, but when the engine starts running, the alternator will start producing power. The voltage there will get to the same voltage as the battery voltage, and the light will go out because there's no difference in voltage between there and the ignition switch power supply. I will just mention actually that when you put these JST type connectors in, they will snap into position quite easily, but if you want to remove them, this one, the 10 pin connector, isn't so bad. You can just push that tab in and pull it out, but the 20-way connector, because it has more pins, is quite tight to remove, so you'll need to pull that tab down, and then get a small flat screwdriver between the edge of the connector and the body of the connector and pry it up. So I'm not going to connect that now. I'm just going to leave that to the side, because the best thing is to wire this connector up as you want it first and then plug it in afterwards. This 6-way connector here is for programming the unit, and if you want to reprogram the unit, we can recommend that you get something called a PICkit manufactured by Microchip, who are the manufacturers of the microcontroller, which is this one right here, and that's a Microchip part number PIC 16F877A, and to reprogram it you'll just need to put a in-circuit programming connector on there and put the other end into the PICkit device, and I'll put a link to PICkit devices in the description below. So let's just remove that. We also have an industry standard RS232 connector, which enables the unit to be connected to a computer with an RS232 port, or a more modern computer with a USB connection via a USB to RS232 conversion cable. Or alternatively, we can talk to the unit via the Knights of England Dash Module 0, which is designed specifically to hook up to all 5 dash modules and communicate with any one of them. Finally, let's look at the dash top indicator connector, which is a 6-way connector, and this is arranged. It will only go in one way, and it goes in with the red and black wires on the right hand side, and again just pushes into position. Now, the dash top indicators, Knights of England don't currently offer dash top indicators, but we arrange our unit so that it will connect to dash top indicator modules from suppliers which are either common high side or common low side. What's the difference between those? Okay, so the common, the usual configuration is a common high side, which means that that one side of all of the dash top indicators is joined together and connected to the positive supply, which comes out on pin 5, the red wire on here, and then the other connections on pins 1, 2, 3 and 4 drive the individual dash top indicators by switching low. The alternative arrangement is the common low side, where we have the low side, the negative side of all of the indicators, joined together and joined to the black wire, which is on pin 6, and then the individual dash top indicator lights drive high, this to 12 volts. Now, if we have this set up incorrectly, if you have your dash top indicators low switched and you have it programmed for high switched, or vice versa, it doesn't make it won't damage the unit. What it will mean is that when the indicators are supposed to start off all off and go on 1, 2, 3, 4, what will happen is they'll start off all on and then they'll switch off 1, 2, 3, 4. So if that's happening, then you need to change the polarity of the dash top indicator drive, and we can do that using the push buttons that we have connected to the generic connector. So you don't need to reprogram the unit to do that now, because the latest version of software enables that to be changed over within the software. Let's just say a quick word about some of the other desktop indicators. Excuse me, let's just say a quick word about some of the other user options on the unit. We've mentioned the polarity, the desktop indicator polarity, which can be changed over. And the way that we do that is we hold the switch, that is switch number 1, in the active position, and then we give a long press on push button number 1. That will enable the polarity, the desktop indicator polarity, to be changed over. The desktop indicators themselves can be programmed to switch off when the lights are on, that is if you have the lights connection connected, and that's something that has to be set in the programming, so that would have to be reprogrammed if you want to change that. The default setting for that is we program it to be such that yes, the desktop indicators do switch off when the lights come on. Another one is that you can program the desktop indicators to go off when you turn potentiometer number 2 right down to its minimum value. Again, that's something which can only be changed within the programming. The normal auto pursuit functions, the functions of the side indicators and the desktop indicators can be programmed to have one of a number of different configurations. We can either program nothing to be functional, that is we're only using the voice display, or we can program nothing to be functional but the other indicators to come on in show mode, that is to keep cycling through the countdown sequence, or we can program the normal and auto pursuit indicators only to be active and the other indicators to just come on all the time. Or we can have the normal auto pursuit indicators functional and the other indicators are in show mode. Or we can have all of the indicators, everything functional, that is the voice display, the normal auto pursuit indicators and the side indicators and the desktop indicators. However, note that in fully functional mode the normal auto and pursuit indicators won't correspond to normal auto and pursuit functions. We'll have other functions on there instead. And the functions that we'll have on there are as indicated in this diagram here. The normal indicator will actually represent oil pressure, low oil pressure, if we have a fully functional mode. The auto indicator will correspond to the check engine light, and the pursuit indicator will correspond to the brake warning light. We also have a user option to dim the side indicators when the lights are on, and we have a user option to dim the voice display when the lights are put on, and by default both of those user options are set true. In other words, when the lights are switched on, provided that you have the lights connection connected, the voice display and the side indicators will be dimmed. Other options which can be changed by the push buttons are as follows. The display can be changed between the kit or the car display format by a long press of push button number 1 when switch 1 is in the off position. Remember, we said that a long press of push button number 1 when switch 1 is in the on position will actually change the polarity of the desktop indicators. A short press of push button number 1 will actually cycle through those different functions that we mentioned for the indicators. So it will cycle round the sequence of nothing functional and all on, or nothing functional but things are in show mode, or normal auto pursuit only are functional and the others are all on, or normal auto and pursuit indicators are functional and the other indicators are in show mode, or everything's functional. And then it will go back around again. So single short presses of push button number 1 will cycle through those options. Another user option which can be changed by a short press on push button number 2 is the way that the side indicators operate. That is, of course, if you're in fully functional mode. Now, the normal way that we have these operate is that when an input is not active, the indicator, the corresponding indicator, is on continuously. And when the input is active, then it flashes. The reason we've done that is to make it look a bit more like the show car, where you usually see all the side indicators on. But the alternative, by a short press on push button number 2, is to have the side indicators operate such that when the input is inactive, they're off, and when the input becomes active, then they come on. A long press of push button number 2 in normal running mode will switch you into show mode. Now, I did promise, or I did threaten, that I'd say a little bit more about alternators for those of you that really want to know. And this gives us a better picture here. If we look here, you'll find that the alternator will have one thick red wire. I don't know why that's drawn as black on there, that's unlikely. But you'll have a red wire going from the alternator output to the battery, and you'll also have a connection between that battery output and one of the small terminals as well. That small terminal is actually the output of the alternator's rectifier. The other terminal, terminal 1, is actually the wire that you need to connect the alternator input of the dash module number 3 to, if you're having it fully functional. And you can see that the way that these alternators operate is that we have a rotating winding which generates a magnetic field, and then we have a stationary winding called the stator, which is actually a 3-phase winding, and that is actually fed to a rectifier bridge comprising 6 diodes and a capacitor. We then have another 3 diodes which take the output to this indicator lamp, which is the output we connect to, and that also feeds back into the regulator here. And the function of the regulator, what that effectively does is it varies the current which is allowed to go through the rotor winding, and that allows the amount of voltage generated by the 3-phase stator to be regulated. Anyway, that's far too much detail for this video. I hope it's given you some idea of some of the functions of the new version 9 of dash module number 3. Thanks.
And this is Carr saying thank you for watching. Goodbye.